Alright, grade 9. So today we're going to start section 5.1 on describing relations algebraically. So first off, we're just talking about a pattern. A pattern that changes at a constant rate can be expressed in a variety of ways. We're going to look at how they can be expressed as a diagram or as a picture, as a table of values, and as an expression. So take for example these toothpicks. I could arrange 3 toothpicks into a triangle. That would be my figure 1. Figure 2, I could add 2 toothpicks to that, and I have 2 triangles. And in figure 3, I could add 2 more toothpicks and get 3 triangles. So those are diagrams, they're pictures. They allow me to see a pattern. I keep adding 2 toothpicks to whatever the previous diagram was. The table of values could be divided up into 2 sections. Could be the number of the figure number, we'll call that N, and the number of toothpicks. We could call that T. So under N, we've got figure number 1, figure number 2, figure number 3, and then in the second part of the table, we've got the number of toothpicks, which is T, 3 toothpicks in the first, 5 toothpicks in the second, and 7 toothpicks in the third. Diagram. Now, we can get a lot of information from that table of values. First off, let's talk about what kind of variables we've got there. On the left-hand side, the number of the figure, that's what we call an independent variable. It doesn't really depend on anything else, it just is. It's figure number 1, figure number 2, figure number 3. The second variable is a dependent variable. The number of toothpicks depends on the figure. If I'm in figure 1, there's 3 toothpicks, but if I'm in figure 2, there's 5, and if I'm in figure 3, there's 7. So the number of toothpicks depends on what figure we're in. We can also talk about something called the rate of change. The rate of change is how much I'm growing by or decreasing by on my dependent variable side. So for instance, if I go from 5 to 7, I'm increasing by 2. My independent rate is increasing by 1. So the rate of change is the dependent over the independent, 2 over 1, or a rate of change of 2. The number of toothpicks increases by 2 every time the figure goes up by 1. I can use that information to make an algebraic expression. The dependent variable, the number of toothpicks, is equal to 2, the rate of change, times the independent variable, so 2n, plus 1, some constant. I can figure out the 1 by going, well, if I go 2 times 1, I get 2, plus 1 is 3. 2 times 2 is 4, plus 1 is 5. 2 times 3 is 6, plus 1 is 7. So here's a situation where you might be asked to represent something with a table. Let's say that Logan is, or Nolan, let's say, is out mowing. He's mowing the lawn. And he charges $10 to show up with his equipment, plus an additional $2.50 for every 15 minutes of work that he needs to do in your yard. Now, Nolan's a hard worker, so we know that he's not going to just go slow so he can make more money because he's not going to get hired again. But if he works hard and people see that he's working hard, they'll bring him back. So $10 to show plus $2.50 for every 15 minutes. So it's going to cost the homeowner in dollars, so variable C, that's the dependent one, based on how much time it takes him to mow the lawn. And if we measure time in minutes, we'll let time equal T, the variable T. So we can go up by 15 minutes, 30 minutes, 45 minutes, 60 minutes. And we do the math and we figure out that if he shows up $10 plus 15 minutes of work, it's going to cost $12.50. Plus another 15 minutes will be $15, then $17.50, and then $20. So a question could be, what is the rate of change? Well, the cost is going up by $2.50, but the time is going up by 15 minutes. So the rate of change is going to be $2.50 per 15 minutes. If I simplify that, if I simply go 2.5 divided by 15, I get 0.16 repeating. Or if I reduce the fraction, I get $1 for every 6 minutes, 1 over 6. So how much is earned for 1 hour, or how much does it cost for 1 hour, I guess, would be $10 to show up, plus $1 for every 6 minutes, or since we're talking about an hour, $10 for every 60 minutes. So the cost for the homeowner, or the amount that's earned by Nolan, is $20 for 1 hour, plus another $10 for an hour of work, so $30 for 2 hours, or $50 for 4 hours. $10 to show up, plus $10 per hour. An algebraic expression, well, we're looking at the dependent variable, so that's the cost, C, is equal to the rate of change, 1 over 6, times the independent variable, T, plus some constant. And the thing that doesn't change here is that it's going to cost $10 every time he shows up at a job site. So the cost in C is equal to 1.6, or 1 over 6 times T, plus 10. If I want to use the formula to figure out the cost for 4 hours, I change the 4 hours into minutes. So 4 times 60 gives us 240 minutes. 1 times 240 is 240. 240 divided by 6 is 40. And 40 plus 10 is 50. So the cost for 4 hours of work on some huge lawn is going to be $50. Worth it? Yeah, up to you to decide. Now, a couple of warm-up questions here. So we've got a couple of table of values where the independent variable isn't in order. Okay, so we've got our x's, and I'll give them to you here. You've got them in your notes already, but I gave them to you out of order. So our input values, 2, 6, 4, and 0, our outputs for those were 5, 13, 9, and 1. So first thing we need to do in order to figure out a rate of change is to unscramble that table of values. Might as well put the independent variables in order. So 0, 2, 4, 6. Then move the dependent variables to the right spot. So that should be 1, 5, 9, 13. And then figure out the rate of change there. We'll get an algebraic expression once we figure out the rate of change. So 1 to 5 goes up by 4. 0 to 2 goes up by 2. 5 to 9 goes up by 4. 2 to 4 goes up by 2. 9 to 13 goes up by 4. 4 to 6 goes up by 2. So it's constant. We can see that the rate of change is the same. We take the dependent rate over the independent rate, 4 over 2. We get 2. So our algebraic expression is going to be y, the dependent variable, is equal to the rate of change times the independent variable, 2x, and then plus 1. Because 2 times 0 is 0, plus 1 is 1. 2 times 2 is 4, plus 1 is 5. 2 times 3 is 6, plus 1 is whatever that was, 7, something like that. Here's another one, all scrambled, so unscramble it. So our table will be 0, 1, 4, 6, and then -4, -2, 4, and 8. Now if we look at the rate of change though, things are different. It goes up 2 for every 1, or 6 for every 3, or 4 for every 2. But those rates are all the same. 2 over 1, 6 over 3, 4 over 2, they're all the same rate of change, which is 2. So our algebraic expression is the dependent variable, y, or our output, is equal to 2 times the input, 2 times x, plus or minus whatever makes the right side true. So 2x in this case, minus 4. 2 times 1 is 2, minus 4 is -2. 2 times 6 is 12, minus 4 is 8. So it works for all of them. With some bigger numbers, and unscrambled this time just to make it a little quicker, we've got 0, 1, 2, 3, 1300, 1275, 1250, 1225. You'll notice that the output is decreasing by 25, while the input increases by 1. That means my rate of change is -25 over 1, or -25. So I've got something, some constant, and I'm taking 25 away from it every time. So at 0, at the initial time, I had 1300. So it's like saying y is equal to negative 25x plus 1300 or 1300 minus 25x. Your assignment is here. Take a look at section 5.1, page 204, number 1, number 3, I think, 5. Well, you can see it here. Okay, so make sure you've written down the assignment, and we'll talk to you tomorrow.